my name's Zach Duncan, and I'm from Otter Products in Fort Collins, Colorado.
Richard Benson from Otter Box, Otter Products in Fort Collins, Colorado.
What's something that you would like beginners to know about 3D printing, CAD software, or the work that you guys do at Otterbox?
At Otterbox, we have a very long history of working with additive manufacturing and 3D scanning. So I've been there for 14 years, and through my whole career at Otter, we have always had we've always had 3D printers and we've always had scanners, and we've evolved over the last 14 years and just continuing to upgrade to newer and newer machines.
Mm-hmm.
What's amazing that I would like people to know is that these hobby machines are extremely advanced compared to 14 years ago. So the use and the ease is awesome. And just like this scanner here, it's amazing for what it is. And for the level in the library to actually have access to this stuff is just amazing for the people that can use it.
I'm a principal engineer at Otterbox right now. I printed my first part in 1995. Back when it was a fairly new technology. It had been around in some form for about 10 years before that, and other forms long before that. But we immediately recognized the value. That was at a time when you released a part for injection molding. It could be 24 to 40 weeks before you saw a part in hand. And being able to have a part in a week and look at it and understand it was a valuable tool to check before you go to spending hundreds of thousands of dollars on an injection molded tool. It allowed our sales and leadership to see those and be more confident in that decision when they released it. It became something that we did before we released any product, then it became iterations, so we were able to do multiple throughout the product development. And as the technology improved, we were able to do more and more with it. Every place I've worked since then, we implemented additive manufacturing or 3D printing or graphic prototyping as it was first known, then into the 3D printing. As Zach said, these machines are very advanced. A machine I had similar to this 20 years ago was a $1.6 million machine. These are now $1,000 machines, very accessible, and with more capability.
Do you have any predictions, either of you, as to what the future will hold with 3D printing, considering we have advanced so much in a short 20, 15 years? Any predictions for how that might change process in the future, or how it can continue to evolve and grow?
Prediction, and it's already starting to happen, is as we start to onshore and bring manufacturing back into the U.S., I think that we really need to look into additive manufacturing for the workforce. That's where the United States is going to have, I think, a really an upper hand on other countries. We're already starting to produce parts, automotive, aerospace, using additive manufacturing instead of traditional manufacturing techniques, because it's gotten so advanced that we're able to do that now. So I think it's just going to continue, and my hope is that additive will be one of those almost the way we manufacture in the U.S. because it makes the most sense.
I would agree. It's becoming additive manufacturing at this point. It's no longer 3D printing. It is making things from constituent materials. Soon we'll be able to make things from variable materials in the same part. Already you can make assemblies without ever having to assemble. But beyond that, it won't replace traditional manufacturing any more than when CNCs came out. There's still manual machine shops out there. It will just become another tool that we'll use more and more often. And we can achieve designs that we can't achieve in any other way. You can print things inside of things and never have to access those. The other thing that I think additive manufacturing or 3D printing is going to evolve into is printing organic materials. within my lifetime, likely within your lifetime, you'll be able to have a replacement organ printed out of your own cells. So your body doesn't reject it. That's already being done. We're already implanting some of those now.
Is there a green advantage towards additive manufacturing as well?
Yes, definitely. So specifically like SLS technology, there is the possibility that you could regrind some of the nylons and then reuse them for particle size. That's just one possibility. In the SLS technology as well, you can continue to use powder over and over and over again out of used builds. So you mix it 50-50 or there's a specific ratio that you can actually mix used powder with new powder. So that brings the sustainability up because you don't have any waste. So a lot of traditional manufacturing, it's you take huge blocks, chunks of metal or whatever, and you make little parts. This, you don't have to do that. So that's all waste, and then it has to go back and be recycled. This, you're taking, you're not doing that. So it's all additive, so you're just using what you need. And with SLS, you can continue to reuse that powder. There's also some really interesting things with supply chain. So you can do regional manufacturing. So you don't have to do shipping halfway around the world. If you have an additive machine sitting in that region or in that state or town or country, you can send a file over there, it can be printed, and you can go pick it up. So huge. That's huge, right?
Would you guys be able to share a little bit about what you're working on today at the library?
Today we're setting up a 3D scanner.
Okay.
One of the problems with additive manufacturing, 3D printing, is getting the data in the computer. You can either have designers that use CAD software to design that directly into it, or in this case, you can take a physical object that already exists, scan it, and put it into the computer to be manipulated, scaled, changed, or added to other things. So you don't necessarily have to have as much skill in that CAD program, although it still takes skill to interpret it. So that's what we're doing right now, is setting up a scanner that the library's had for a little while, but they haven't had the resources to really get up and running. Zach especially has a lot of experience in the 3D scanning and is very impressed, I think, with the quality of the scanner.
Yes, it's pretty impressive for, some of the first scanners that I used, they were a lot more expensive than this, guaranteed. And it took a long time to get what we're just getting here on the screen with the initial pass.
Are these types of changes going to make 3D printing more accessible to beginners, or is this more of an advanced skill set to continue to build upon with beginner CAD knowledge?
I think it's both.
Both, okay.
And especially at facilities like this that you have, just getting people in, getting them a taste of the real, I don't want to say simple, but the easy to use software, that's going to spur on, hopefully the appetite to look into more advanced softwares and continue on. But yeah, this is, what you have here is pretty impressive.
And with Loveland is a sculpture town. We do a lot of sculpture in Loveland. We have 2 or 3 foundries, and being able to do a small sculpture in clay or wax, scan it in here, bring that in the computer, have that enlarged, have that printed out or CNC'd out of foam, and then the sculptor finishes that, puts the textures on it, and sends that to the foundry, is an application that's being done right now. There's an industry in Loveland and other parts of the state and the world to already do that, but to have that resource at the library for a sculptor that may not be able to afford those resources opens that up quite a bit as well.
Thank you guys so much for being here. We really appreciate it, and we look forward to having everyone continue to grow in their 3D printing and scanning knowledge. But thank you.
Thank you.
launched